Hi guys, welcome in Hack Learning for All. If you're a student of a university or you're doing maths at college level and you want to excel in integration, then you are at the right place. I hope you like my previous videos, and today I've brought a new video for you in which I'm going to tell you how to integrate powers of tan and sec. And I have this integral. You can see integral tan mx sec n x dx. And here is a case 1 for you. In case 1, we are going to discuss when sec has an even power and tan has any other power positive integer including 0, then how we solve it. So I have this example 1 for you, in which you can see the integral tan 9x sec 4x dx. Right? So first we have to understand the crunch idea of this type of integral. You can clearly see that sec has an even power and tan has an odd power. So just remember, for this type of integral we have to break sec in such a way so that the first sec must have a square power and the other sec has 2 less powers than the original one, right? Which is sec square x again, and then dx, because this is sec 4x. So I have broken it down like this, and tan 9x. And after that, this is the first step, main step. And after that, what you have to do, you have to convert this sec square in tan. How? We know that 1 plus tan square x is sec square x. So I can use this formulation here. This is tan 9x. And I can write down this sec square by this way. 1 plus tan square x. And then this sec square x dx as it is. I'm keeping it. Let's remove this one so that we will have more room. I'm keeping this sec square dx because later on we are going to use substitution. And we will need the sec square term later on. Here I can use substitution, and we know that in substitution we take one term equal to u, and here I can take tan equals to u. Why? Because the derivative of tan is sec square x, which is already present next to it. So when I differentiate it, so it is equal to sec square x. This is the reason I was keeping sec square as it is. I can further write down this du by dx by using chain rule. Du by dx into dx sec square x dx. And I can say this and this equation number 2. And I can say this equation number 1. Now I have to use the values of 2 in 1. And when you do that, so equation 1 will be tan 9x. I know tan x is equal to u from here, equation 2. So I can write down u9. 1 plus tan square, which is u again. 1 plus u square. Sec square x dx is du by dx into dx. So I can replace this value here. Du by dx into dx. Alright. Now it's pretty simple. I have to multiply this u9 with every term. So it is u9 plus u11 du. And then we have to integrate every term separately. u9 du integral u11 du. When you integrate it, so it will give you u10 over 10 plus u12 over 12 plus c. And now we can substitute the value of u, and we know this is tan x from equation 2. This is tangent of tan x over 10 plus tangent 12x over 12 and plus c. Alright, so this is the first example of this case in which you can see sec has an even power and tangent has any other power, positive integer. In this case 10 was 9, which was odd. I can give you another example so that you can understand more. Here we take integral sec 8x dx. So I'm sure you remember the crunch idea that how to break it. Yes, first term will be sec square and then other term will be sec 6x dx. As we did before, the first term must have a square power and the other sec will have 2 less power than the original one, right? So you have to remember that how we break it. And I can write down the sec 6x as sec square x cube and then sec square x dx. I'm keeping it because we need it for substitution. Why I have broken this sec square x as sec square x cube? Because I can use this formulation in here. Alright, so I can write down the sec square x as 1 plus 10 square x cube and then sec square x dx. Now what we are gonna do? Yes, we are gonna do substitution. So let u equals to 10x du, the derivative of 10x is sec square x dx, or I can write it down by chain rule, du by dx into dx sec square x dx. You are wondering why every time I say I can write down by chain rule. I can write down this du as sec square x dx, but pure mathematicians, they do not accept it. They say no, this is not right. So that's why we use by chain rule and we multiply dx here on both sides, and according to pure mathematician this is right. This is the right way to write down this term. That's why I show you every time that by chain rule how we write it. Okay, so this is not right, we remove it. All right, so this is equation number 1, this one and this one equation 2. Now use equation 2 in 1. We get integral 1 plus u squared cube and sec square x is du by dx into dx. Now how to solve it? So if you have done at a school level a plus b whole cube formula, I'm sure you remember it. A cube plus 3a squared b plus 3ab squared plus b cubed. Yes, we have to use this formulation in here. This is a and this is b. So let's use this formula in here. So a, which is 1 cube, a cube plus 3a, which is 1, b, a square, 1 square, b, which is u square, plus 3a, which is 1, b square, u square and whole square, plus b cube, which is u square and then cube, and then du. All right, now we can see this form after expansion of this a plus b whole cube, right? Now I can also write it down by this way: 1 plus 3 u square plus 3u4. I'm further simplifying it, u6 du, and then integrate every term. So du plus constant is outside the integral, u squared du plus 3u4 du plus integral of u6 du. So the integral of du is u plus constant. The integral of u square is u cube over 3. You can cancel 3 with 3 plus 3 here. The integral of u4 is u5 by 5 plus the integral of u6 is u7 over 7 plus constant of integration. And now this is the time to substitute the value of u, which is 10x from here, from equation 2. So I can write down 10x. I'm substituting the value u plus 10 cube x plus 3 by 5, 10 5x plus tangent or tan 7 over 7 plus c. So this is the second example, and I explained you in detail how we solve these type of integral when sec has an even power and tan has any other power. Alright, I hope you like it. I'll see you next time with more videos. Thank you.